Blendy friends. Today I'm going to be showing you the AI progress in the game and the preloader. But first, don't be afraid to be a weirdo. Just because everyone else is using a different tool doesn't mean that you have to use the same tools. So, I'd like to thank my patrons for supporting my project using the Blender game engine. Without any of you, the project would no longer be alive. So, I thank you guys very much for your support. And let's get right into the video. So, over here you can see a Blender scene. What's great about Blender is every Blender file is like a zip file. That means it's a library. It stores materials, textures, animations, masks, meshes, armatures, all sorts of things like that. And for a game, this is great because all these things are combined in a 3D game. So actually, if you ever try to append a Blender file, you can actually see, look at all these different folders and then all the materials in that folder. So it's just a library. The problem is that it's very difficult to load Blender files asynchronously in the Blender game engine. So I had to come up with a creative solution. Now, this solution is inspired by Tim Krellin's solution that he has up on YouTube about how to drag a camera backwards through a scene. Blender only loads items when they load into the scene. So that means when the camera sees it and the bounding box is within view of the camera, then it loads that object, which causes stuttering. So I very simply made a visual solution. So you can see here a preloading bar, and there's a black background, and there's a camera. So far everything looks pretty innocent. This is where things get a little weird. I have a piece of code that drags the camera backwards along the x-axis. And along this whole x-axis, you can see, is every item in the game, kind of like a big conga line. So as the camera drags backwards, each item eventually falls into view of the camera, and the Blender game engine loads it. At the same time, the progress bar increases in scale as it gets closer to its goal. So you can see here all the items in the game passing through the camera above the top. Now, you wouldn't see this if the materials were turned on, because when I turn the materials on, you see a black background, and then you see a preloader here loading every item in the game. Simple. This is how it works. It's actually a very simple piece of code that allows you to add a single empty, and then any item that you designate needs to be loaded, you add it to the group loading items. So if I go over to this main scene over here, you'll see all these items just lined up, and each one is part of the group loading items. So loading items need to be loaded, and that's it. Once they're all part of this group, this is the instance that allows each item to appear in the game scene, and then the camera drags backwards. Over here you can see it. It walks backwards through this scene until they're all loaded. Then it switches to the main scene. So that perfectly dovetails into the second part, which is I'm going to show you the current progress of the end objects in the AI tracking system. So in my previous devlog, I showed how I needed to combine navigation meshes in random order so that the monster can traverse multiple randomly sourced terrain blocks and chase the player. So to do that, I made a new piece of code, and here's my big question mark that's working right now. So this actually is, I called it the question mark just because it's kind of fun. It's like the AI, where's the player? And you can see it's running a simple controller, and it's just a Python module controller. And right now this means to keep continuously reloading the script so you can test it while you're using it. So if I press P to test, you can see there's the world. I'm going to do something different though. I'm going to turn off the player camera, and we're going to stay high above everything so we can kind of see a God's eye view of what's going on in the scene. So right now I have a function that just makes the player camera the default, but I'm going to turn that off, and we're going to look just from space essentially, and we're going to be able to see the exit objects tracking the player. So here you can see a vertical bar that's pink, and that pink vertical bar, that's the exit object for the main terrain block. And if I run in this direction, you can see, now obviously the player is running supernaturally fast for testing purposes. Every 25 meters, that pink bar updates and tracks the player. If I leave the bounds of that specific terrain block, you'll see a new exit object appears, and this is the orange bar. Now you can see how they're tracking my last best known position. And this is what the AI is going to use to track the player. So if I run back over here, now I get handed it off again to the pink bar, and the orange bar is now left to track me. So it'll track my last known position or best known position, so that if the monster is on the previous block, it'll say, I need to go to the orange bar, which will then hand it off to the main terrain block with the pink bar. Similarly, if I go in this direction, I will get handed off to another AI tracking bar over here. And this is pretty much how it all works. So you can see the green triangles actually for tracking the player, just to see where things are going. And if I go this way, now it's tracking me this way. So this is how I'm going to basically daisy chain together random navigation meshes so that the monster can always track the player. If you run even further beyond the realm of these, what I would call terrain blocks, you can see if I run very far away, the terrain blocks will unload, and now the player is completely gone. And this is also going to be a problem as well, because after 3 blocks, the world origin sets back to 0, so we need to have each terrain or exit object block be an empty that's parented to a terrain block, so it uses local scale rather than global scale, because the global scale will constantly be reset and set the player back to the player origin here. This is to make the game stable, because if you go too far in any one direction, stability becomes an issue as well. So that's a little complicated, but my patrons will be able to test the file and also see how it works. And I love if you have any questions about how this is being done, feel free to leave a comment in the section below. And thank you guys so much for your support. I really appreciate it, and I will be jumping off now.
The sound